Hi, I am Lopamudra Sen. Welcome to my channel Electronic Science Tutorial. Today I will discuss the next problem of NET question paper, which is based on the topic of electrical conductivity. So let's start our class. So what is the question? The question is, what is the resistivity of intrinsic germanium at 300 degree Kelvin given that its carrier concentration is 2.5 into 10 to the power 13 per centimeter cube and electron and hole mobility is 3800 centimeter square per volt second and 1800 centimeter square per volt second respectively. This question is from UGC Net 2012 Electronic Science, 2012 Electronic Science question paper. Okay, this problem. The first option is 0.446 ohm centimeter. Second option is 44.6 ohm centimeter. Third option is 0.022 ohm centimeter. And the last option is 22.2 ohm centimeter. How can we solve this problem? What is given in this question? In this question, the given value is Ni. That is the electron concentration. Ni is given. What is the value of Ni? The Ni value is 2.5 into 10 to the power 13 per centimeter cube. This is the intrinsic carrier concentration value. Then in this problem, given value is electron mobility, that means mu n. What is the mu n value? Mu n value is 3800 centimeter square per volt second. Then the given value is mu p. What is the value of mu p? Mu p value is 1800 centimeter square per volt second. So these values are given in this question. Intrinsic carrier concentration, that is equal to 2.5 into 10 to the power 13 per centimeter cube. Electron mobility, that is equal to 3800 centimeter square per volt second. And the hole mobility, that is 1800 centimeter square per volt second. So these values are given in this question paper. And what we know? We know the electronic charge or the Q value, that is equal to 1.6 into 10 to the power minus 19 coulombs. So we know the electrical conductivity, that means sigma equal to Q n mu n plus P mu p. If the carrier concentration is intrinsic carrier concentration, we consider then N and the P, that means the electron concentration and the hole concentration, that is equal to N equal to P equal to Ni. That is the intrinsic carrier concentration. So what can we write? We can write Q into Ni into mu n plus mu p. So we get the value of electrical conductivity. And if we get the electrical conductivity value, then from this value we get the resistivity value. Resistivity is equal to rho equal to 1 divided by electrical conductivity. So if once we get the electrical conductivity value, then we get the electrical resistivity value. Okay. So this is the solution. The first, here the given value is the intrinsic carrier concentration Ni equal to 2.5 into 10 to the power 13 per centimeter cube. Next given value is electron mobility 3800 centimeter square per volt second, and the mu p value is 1800 centimeter square per volt second. So what we get the resistivity value. Resistivity is equal to 1 divided by electrical conductivity. That means 2.5 into 10 to the power 13, that is the intrinsic carrier concentration, into 1.6 into 10 to the power minus 19 into mu n plus mu p. What we get 44.6 ohm centimeter. Okay. So the right option is 44.6 ohm centimeter. So this is the solution of this problem. I hope you understand this topic. Thank you. Thank you. If you like my channel, please like, share and subscribe my channel. Thank you.